Welcome to the box method to find area part 2. Alright, so we're going to find the area using the box method of two polygons. Here's the first one. Alright, so our first step, of course, is to box the figure in a rectangle. Make sure you start at the leftmost point. Right, so there's the leftmost point. You can stop when you get to the uppermost point right here. This whole side is the uppermost. We're going to continue till we get to the rightmost point, which would be there. And then just finish off your box. Right? You should see that the vertices of the polygon you're finding the area of using the box method should all be on your rectangle. Right, so we've boxed our figure in. That's step 1. Step 2, we're going to find the area of the rectangle. Nice and easy here because we have nothing but vertical and horizontal lines. That's the beauty of the box method, is you always have a rectangle with nothing but horizontal and vertical lines. Right? So on this side here is 3. Okay? And it's perfectly fine to count the boxes on this one because the scale is 1. Right? Every one of these boxes is worth 1. Right? If it wasn't worth 1, right, then we would want to use the difference in the coordinates. Right, and along the bottom there, our box is 1, 2, 3, 4, 5, 6, 7. Right, goes from 5 to -2. That would be 7. Right, so to find the area of the rectangle there, our area would just be base times the height. Right, here the base 7. Height of the rectangle is 3. So that means the area is going to be 7 times 3, which is 21 units squared. Now we need to find the area of the triangles. There's 2. We have a triangle here and a triangle here. Right, so let's find the area of triangle 1 first. We need to know the base and the height. Right, by the way, all of these triangles, the reason we can use this method is that our outside figure is a rectangle, super easy, base times height, and what we're subtracting off is always right triangles, right? Because one of their angles is one of the angles from the rectangle, and we know a rectangle has all right angles. All right, so to find the area of a right triangle, just a little reminder. The base is a leg, and the height is a leg. And it really doesn't matter which leg you call base and which leg you call height. And I have a tendency to make the vertical one be the height and the horizontal one be the base, but it really doesn't make any difference, right? But for a right triangle, those legs are going to be your base and your height, because base and height have to be perpendicular to one another. Okay, so the base of the triangle has to be perpendicular to the height. Okay, and where the two legs meet, that's our right angle. So we know that those two legs are perpendicular. All right, so I'm going to call to this side here the base. Right, so that's 2. And then the height is just 3. It's the same as the rectangle height there. Matter of fact, I won't even write it in again. I'll just move this one over. Right, so our height is 3. And of course, this is a triangle, so it's going to be 1/2 base times height. So the area of triangle 1 is going to be 1/2 times 2 times 3. Right, so half of 2 is 1. 1 times 3, that's 3 units squared. Always remember your units. Right, and now we want, I labeled both of them triangle 1. I must like the number 1, I guess. We've got triangle 1 and triangle 1. Didn't even notice. Triangle 1 and triangle 2. All right, not a big deal. Right, so we want to find the area of triangle 2. Again, we're just going to take 1/2 times the base times the height. Let's find our base and height. Let me move this down just a little bit so I have a little bit of space to write base and height. All right, so we'll call this one the base. That right there, that's the base. Let me make that a little neater. Trying to distinguish it from the 2 that I just put in the middle of the triangle, which is just labeling the triangle. There we go. That's 2. And then our height from here to here. Look how nice I did that. I should have done that over here. Got pretty. So pretty. Our height here is 3. So exact same dimensions, 2 and 3. So the area of triangle 2, 1/2 times 2 times 3, which is also 3 units. And which I have no place to write, so we'll just move that down to give me a little bit more space. So the area of the polygon, we just have to take the area of the rectangle and subtract the area of the triangles. So the area of the polygon equals the area of the rectangle. That was 21 units squared. You don't have to write the units squared to get to your answer. And then you're going to subtract the area of the triangles. You have to add them together. We had 2. They were both 3, which is going to give us 21 minus 6, which is 15 units squared. And there we go. We have found the area of our parallelogram by simply finding the area of the rectangle that boxes it and subtracting off the triangles. Okay, let's look at the last problem that we're going to find the area of using the box method. All right, so we're going to draw and classify the polygon with the following vertices. This is in your notes. I made sure to make mine match yours, so that would be easier for you to take notes. All right, so we have h is at -3, 4. 1, 2, 3, 1, 2, 3, 4. And for once, I can actually see the coordinate grid. Usually I'm struggling there going, well, I think that's 3. I can actually see all of the lines. It's so nice. All right, so, and I'll write, actually, you know what? We have them written above. It might get too busy, so I'm going to leave that off. All right, so let's continue graphing. Though J is at 2, 6. So 2, 1, 2, 3, 4, 5, 6. There's J. K is at 2, 1. And L is at -3, -1. There we go. And we'll just connect our lines. Usually it's a good idea to use a ruler to do this. And then you don't get one that looks like that. Oh, there goes the whole thing. Let's see, so I don't have these horribly crooked lines, if I could use a line tool. All right, let's try to use a line tool. Here we go. 1, 2, 3, and 4. There we are. So pretty now. All right, so we've drawn the polygon. There it is. We need to determine what kind of polygon this is, right? Because that was one of our directions, right? It said we had to find the perimeter and the area. It's a good idea, by the way, if this was a formative, that you underline those keywords so you don't make a mistake and find the wrong thing. Right, so we were also asked to classify the polygon. So we're asked to do all these things: classify it, find the perimeter, and the area. All right, so one thing we'll be learning in the second semester is we'll be learning all about parallelograms. One feature of a parallelogram, where it gets its name, is that both pairs of opposite sides are parallel. That's why it's called a parallelogram. If they weren't parallel, they wouldn't call it a parallelogram. They'd call it something else. So if both pairs of opposite sides of our parallelogram, HL and JK, and HJ and LK, if both those pairs of opposite sides are parallel, then our polygon here, HJKL, is a parallelogram. So we're going to use the slope to determine the type of polygon and see, is this indeed a parallelogram? If we don't get the opposite sides parallel, then it's not a parallelogram. Right, so we're going to find the slope of HJ and KL Right, so I have the slope formula right here, and it is also in your notes. Remember, when we find the slope of a line, we take the difference in the y-coordinates over the difference in the x-coordinates. And it doesn't matter who's first, right? It just matters that the y is in the numerator and the x is in the denominator, and you match up the points. All right, so we're looking at h and j. I'm going to, ooh, that isn't that pretty. Underline it. Actually, I'm going to write it next to it. I said I wasn't going to, but I think I am. Just so I don't have to keep looking up. And look at j. We got x. They couldn't put a 6 over there. No. Got an x coordinate on one line and a y coordinate on the other line. So we'll just put this way over here so it's not in our way, but we can still see it. There we go. All right, so we're finding the slope of hj. So the difference in the y coordinates would be 4 minus 6 divided by -3 minus 2. Right, so 4 minus 6, that's going to be -2. And -3 minus 2 is a -5. Those negatives will cancel out. That's just going to be 2/5. I'm not going to move it because it's all connected. How about I move you over just a smidge so I can fit 2/5 in there. There we go. We squeezed it in. All right, so now we need to find KL. All right, so we take the difference in the y-coordinates. So we have 1 minus a -1. Of course, that's going to be a plus. And then divided by, so I started with k, I got to continue with k, 2 minus a -3. So that's going to be 1 plus 1, which is 2, and 2 plus 3, which is 5. And look at that, they are the same. So we figured out one thing. We figured out that HJ is parallel to KL. But that's not enough to say this is a parallelogram. Right? We have to find JK and LH. Right? So same thing. You know, I'm going to actually switch colors here. It's a lot of blue. Let's throw in some green. All right, so let's find the slope of JK. Right? So you could use the slope formula. I'm going to use the slope formula, and then we'll talk about what kind of line this is. So take the difference in the y-coordinates, 6 minus 1. Difference in the x-coordinates, 2 minus 2. Well, we have 5 divided by 0. Well, this is a vertical line. We know vertical lines have undefined slope. How about our other line, HL, or LH? I don't remember which way I had it written before. Not that it really matters. Actually, if I look at your notes, I had LH. Oh, I even gave you the slope. I just noticed. You don't even have to write this down. You can just listen to me on this part. All right, so LH, take the difference in the y-coordinates, and we have -1 minus 4 divided by -3 minus a -3. All right, so that's going to be -5 in the numerator, but nobody cares what's in the numerator because 0 is in the denominator. You've got -3 plus 3. So again, this is an undefined slope. Well, undefined is the exact same slope. Vertical lines are parallel to one another. So we now know that JK is parallel to LH. And actually, I have forgot one little thing. These are line segments. They don't continue on forever. So we need to do that to show that they are line segments. And actually, everywhere I should be doing that. Shouldn't be lazy here and leave that off. All right, so now we have determined what kind of polygon this is. All right, and so let's write that in. All right, so we can write in wherever we can find some space. I'm going to write it over here. Since HJ is parallel to KL and JK is parallel to LH, I'm going to move this out of the way. In the second semester, we'll actually be doing some coordinate proofs, which are kind of similar to what I'm writing here. All right, so we've shown that we have the opposite sides are parallel. So both pairs of opposite sides of the polygon are, I'm going to abbreviate parallel. Parallel. This is a symbol. This symbol here means therefore. Therefore, this is, what did I call it? HJKL. Actually, it wouldn't matter if I call it what letters I started with, but I want to call it the same thing as I have up there. HJKL is a parallelogram. There we go. We have proven that this is a parallelogram, without a doubt, because it's got both pairs of opposite sides parallel. So now we're going to find the area and the perimeter of our polygon here, of our parallelogram. Let's find the perimeter first, because it's a little easier before I go boxing my figure so that we can use the box method to find the area. Let's just find the perimeter first. All right, so HJ, we need to use a distance formula on that one. All right, so we just take difference in the x-coordinate squared. All right, so that's going to be -3 minus 2 squared. And then plus difference in the y-coordinate squared, 4 minus 6 squared. Right, and hope I have enough room to finish up. All right, so -3 minus 2, that's -5. And 4 minus 6, that's a -2. And then we'll just simplify that. So we have 25. And that would be, so that's -5 squared, that's be 25. And -2 squared, that's going to be 4. Right, so that would be the square root of 29. We have HJ. Now I took a lot of space for HJ. You might be thinking, oh, by the way, in your notes for some reason, I have no idea why it says HJ equals HJ equals. No idea. HJ equals. I write HJ? I don't know. Can't explain that. Just make the other ones JK and KL. You already have LK. All right, so I took up a lot of space to find the perimeter of HJ. Fortunately, I don't need to use a whole lot of space to find the perimeter of JK. It's a vertical line. You can just find the difference, the absolute value of the difference in the y-coordinates. All right, so we're just going to take the difference between the y-coordinates, which is the difference between 6 minus 1. So the absolute value of 6 minus 1 is equal to the absolute value of 5, which is 5. Let's find LK. And this time we need to use a distance formula because this one is a diagonal line. Maybe I should box this one in because it's kind of like smushed in between the other one. Maybe I'll switch colors too. All right, so KL, take the difference in the x-coordinates. Right, so that's going to be 2 minus a -3. And then we have 1 minus a -1. Oops. I said 1 minus a -1. I did not say 1 minus 1. 1 minus -1 squared. Gets a little tough to write at the bottom of the screen here. All right, so that's going to be 2 minus a -3, that's just 2 plus 3. And so 2 plus 3, we know that's 5. And then 1 minus a -1, that's just 1 plus 1. So that's just 2 squared, which is 25 plus 4, square root of 25 plus 4, which is the square root of 29. Don't drop off that radical there, right? 29 is not the same thing as square root of 29. We want the square root of 29. LK, fortunately, does not need much space. It's a vertical line. We'll just take the difference. Oops, I have KL and LK. They're the same thing. I didn't do that up there. All right, HJ, we got HJ, we got JK, we got KL, we need LH. LH is the one I'm missing here. So you have LK, but you don't have LH. Just scribble those out and write the right ones in here. All right, so for LH, it's a vertical line. We just take the difference in the y coordinates. All right, so, and it doesn't matter who I start with. I could start with 4. I could start with -1. Right, if I'm taking the absolute value, doesn't matter. I'm going to start with -1, just to be different. So we have -1 minus 4. Well, that's the absolute value of -5, and the absolute value of -5 is the same as the absolute value of +5. It's 5. So now we can find the perimeter. We're just going to add up all of our sides. Right? Actually, I'm going to move this up because I have the space. So the perimeter is just HJ plus JK plus KL plus LH. Make sure you're getting all of this in your notes. This is a really important problem. It's got a lot of stuff in it. Right? We've got perimeter, we've got area, we've got types of polygons. We got everything in here. We got the box method. So we're going to find the perimeter. We're just going to add these up. I'm just going to P for perimeter now. So we've got, and these need this, as do these. So HJ was the square root of 29. And then JK was 5. And KL was the square root of 29. And LH was 5. Now, some of these are like terms, and we can add them together. The ones that we can add together, of course, are 5 and 5. But we could also add the square root of 29 and the square root of 29 because they are the exact same number under the radical. So our perimeter is just going to be 5 plus 5, which is 10. And how many square roots of 29 do we have? Why, we have 2 square roots of 29. I see 1 over here and 1 over here, plus 2 square roots of 29. That is our perimeter. Dun, 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 dun. There we go. Right, we're half done. Actually, we're more than half done. All we have left is the area. Boy, I squeezed a lot into this page. All right, so now let's find the area using the box method. So we're going to box our figure. Right, and I'm going to start over here. Right, always look to a point. You just always start somewhere that is the lowest point and the most and the lowest in both directions, right? So vertically and horizontally, right? Choose that point, right? Choose a point that is definitely a good place to start. So starting at -3 is a good place, right? -3, I'm going to be able to box in that H. Starting at -1 is a good place. I'm going to be able to box in all the other values. If I were to start at K here, right, and just think, okay, I'll just start here and go da 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 da, and then I say, oh, I have to come down here, right? Well, then I have to remember to like continue the box, right? So it's probably easier just to choose the lower point to begin with. Well, ooh, I didn't mean to do that. All right, well, the box is fine, right? If you start here, though, you can just go across. This was a perfectly good tape. And then I'm not even touching anything. Not even touching anything. The only thing I'm touching is my pen. All right, so we have our figure all boxed in. All right, so now let's find the area of the rectangle, the area of the two triangles. Some reason I labeled them C and D, probably so I wouldn't have 1, 2s, and 3s all the time. And then get that confused with measurements. So this is going to be C, and this is going to be D. All right, and then we're going to find first the area of the rectangle, and then we'll find the area of the triangles. So remember, area, of course, of a rectangle is base times height. All right, so let's just identify our base and our height. Right, so I like to call the bottom the base, even though it really doesn't matter. You're just multiplying two numbers. The order they're listed in really makes absolutely no difference. Our scale is 1 here, so it is fine to count. So 1, 2, 3, 4, 5 is our base. Our height, 1, 2, 3, 4, 5, 6, 7. All right, so that means the area of our rectangle is 5 times 7. which is 35 units squared. I want to try to keep it all in one line. There we go. 35. I'll put U for units. U for units is fine. Oops, no, don't move that. I can never tell where the little things are to grab stuff. I just wanted to move the area of the rectangle. All right, so now let's find the area of triangle C. All right, so we need the base and the height. All right, so I like to, you can call either one the base and either one the height. Maybe I'll call this one here the base. Okay, these are right triangles, so we just need to multiply. The base and the height are going to be the two legs of the right triangle, the thing that's not the hypotenuse, because this is a right angle, and that's a right angle. All right, so this is 2. So I'll call base 2. And then height 1, 2, 3, 4, 5. So our base is 2, height is 5. All right, so remember, area of a triangle is 1/2 base times height. So the area of triangle C is going to be 1/2 times 2 times 5, which is 10 units squared. There we go. 10 U's squared. All right, and now we have triangle D. All right, and I'll call this one the base. Actually, maybe I'll call this one the base, just because. All right, so if that's my base there is 5, as you can see. We already have a 5 in there. And the height would be between those two. Right? So the height of that triangle, as I squeeze it in, is 2. So we have a base of 5 and a height of 2. So the area of our triangle is going to be 1/2 5 times 2, which is, oh my goodness, not 10 units squared. Just decided to forget all about the 1/2. 5 units squared. Half of 2 is 1. 1 times 5 is 5. So now all we have to do, if we can squeeze it in somewhere, is find the area of the polygon. So the area of HJKL is the area of the rectangle. I need lots of little boxes in here. Area of the rectangle, or I need to learn how to write smaller. We'll just box this one in so we can see where this ends. Yeah, I just totally need to write smaller. All right, so area of the rectangle was 35. And then we'll just subtract the two triangles, 5 plus 5. And that's going to give us 35 minus 10, or 25 units squared. There we go. We have figured it out. And I think that's the end of this podcast. Because the next thing is on the next podcast. Well, thanks for watching the box method to find area. And if you have any questions, let me know. Bye for now.